How do we graph inverse trig functions? We're going to be graphing inverse sine, inverse cosine, and inverse tangent today. Let's start with sine. So, our original sine graph looks like this. We have equilibria at all the multiples of pi, a maximum at pi over 2, and a minimum at negative pi over 2. If we start graphing x equals sine y, that's not a function anymore. But we can graph it. It's the reflection over the diagonal y equals x. So it looks like this. We have it. The equilibrium is now the y-axis instead of the x-axis, and this is what our graph is going to look like. This would be the function if it were a function. It's not a function because it fails the vertical line test. So we have to restrict it. If we restricted it up here between 0 and pi, then we still would fail the vertical line test. So what we typically will do is restrict it between pi over 2 and negative pi over 2. So this will create our arcsine function that goes from 1 comma pi over 2 down to the origin, and then that goes to negative 1 comma negative pi over 2. You do need to know what these points are, and you also need to know that this is not straight. This should be curving up and then curving down. Let's do cosine now. Cosine starts at a maximum, goes to equilibrium and then a minimum. In the other direction, it goes to equilibrium, then minimum. So if we reflect that over a diagonal, we'll be switching x and y. So 0, 1 becomes 1, 0. Here are our points. So hopefully you agree that this is what x equals cosine of y would look like. But this is still not a function because it doesn't pass the vertical line test. If we did the same restriction between negative pi over 2 and pi over 2, we still would fail the vertical line test, so we need to go from 0 to pi here. So we'll go from pi down to 0. So starting there, going backwards to negative 1 comma pi, and this is 1 comma 0. This is 0 comma pi over 2. What does tangent look like? Tangent starts at equilibrium and has asymptotes. The period is pi, and those asymptotes are half a period away from the equilibria. So this is what our tangent graph looks like. And then there's another equilibrium there, another equilibrium here. So this is generally what tangent will look like. However, we need to find inverse tangent, so let's reflect it. What's going to happen is each of those asymptotes will change from vertical asymptotes to horizontal asymptotes. We still have these points. And now our graph looks like this. We have multiple periods of this, so go with that. So this is what x equals tangent of y is. A bunch of these, infinitely many of these layered on top of each other, just like tangent has infinitely many of these layered next to each other. It's a pretty straightforward restriction for arctangent. It makes sense to restrict between the two asymptotes. So we set the asymptote at pi over 2 and negative pi over 2. Graph 0, 0, 1 comma pi over 4, negative 1 comma pi over 4, and then we make our ascending graph. It looks deceptively close to sigmoidal or logistic curves, and it's really hard to tell them apart. So let's summarize. If we have sine, sine goes from here up to here. Cosine goes backwards. And tangent looks really close to logistic curves. So here are arcsine, arccosine, and arctangent. Please have these memorized.